What's the difference between along track and in-track orbits? Here you see two satellites flying in the low Earth orbit. They have the same Keplerian elements except the mean or true anomaly. The angular separation in this case is about 45 degrees, and these two satellites are in so-called along track orbit. If you're not familiar with the Keplerian elements, go check out the video whose link I posted in the description. Alright, now let's check their ground tracks. If you check the polar regions, the two satellites have overlapped ground tracks, but in regions like this, there's a significant offset between the two ground tracks. If you want to have a group of satellites with the same ground track, in that case, along track orbit is not useful. In that case, you'd need something called an in-track orbit, which looks like this. Alright, here the chaser satellite has the green orbit, and the target satellite has the red orbit. Their orbits overlap near the poles. Here, this is the south pole, and the maximum separation between their orbits happens near the equator, or at the equator. This blue line is the equator. This is an indication that the two orbits have equal inclination, but there's a slight difference in their right ascension of ascending nodes. Alright, let's see their ground tracks. As you can see here, the two satellites have the exact same ground track everywhere. For this simulation, I have considered the Earth to be a perfect sphere for simplicity. Of course, for more realistic simulations, you should definitely consider the flatness of the Earth, at least J2. And in that case, in order to get the same results, you should use the Brouwer-Lindon mean orbital elements instead of the normal Keplerian elements. I will show you a MATLAB script how to generate an in-track orbit. Alright, here RE is the radius of the Earth in meters. Mu is the Earth's gravitational parameter in meter cube per second square. SMA stands for same major axis. And the two satellites have the same major axis. Delta anomaly is the angular separation between the two satellites, and that's set to 45 degrees. Of course, you can select any value you want. Omega is the Earth's rotational rate, and is the mean motion, which is the average speed of the satellite over an orbit. And delta time is just the time counterpart of delta anomaly. Delta time is the duration taken by the trailing satellite to come to the position of the leading satellite. Rotation Earth is the angle rotated by the Earth in delta time duration. In order to generate an in-track orbit, the right ascension of ascending node difference between the two satellites should be equal to the rotation of the Earth. You can put these values for the two satellites in any orbital mechanics tool such as GMAT, orbital, or SDK, and come up with the results as shown here. Alright, if you have any question, let me know in the comment section below. For this example, I used the Keplerian elements of the target and chaser satellites mentioned here. Notice how the right ascension of ascending node and the true anomaly values of the two satellites are related to each other.